Okay, lastly, arc length. Again, this is intimately connected to just the definition of the radian. If we remember that, what is a radian? A radian is the angle that cuts off the length of the radius on the outside. Okay, and so if we were to scale this up, let's say we wanted to find out, well, how long is this piece of the circle? Okay, for a circle of radius r. Well, we call that S, and we say that S is equal to the length of the radius times the angle. Okay, and this has to be in radians. This doesn't work if it's in degrees. All right, and there's a few ways you can think about this, but this is really the best way is to kind of come back to the initial definition, that this total length is equal to the length of the radius times the number of radians. Okay, and you can divide the r over. You could say aka this is the same as theta equals s over r. That's one way to find what the angle might be. Okay, or that r, if you're looking for the radius, let's say, same as the arc length over the angle it took to get there. So these are three ways to kind of look at the same problem, but really this all stems from here. If you scale up the angle, 1 radian, that will be equal to the length on the outside. Okay, so then to just give a simple example of this, we could say how long is the outside of a circular track starting at the initial position on the x-axis and rotating around, let's say 5 pi over 4 radians. Oh, and the track is let's say 200 feet across. All right, so again, we can kind of sketch this out even though I have that circle up there. Got this circle here. Let's say we're starting here. We are at a length out here of 100. Why 100? Because it's 200 across. So it's a radius of 100. And then we sweep out 5 pi over 4 radians. So that is, if you want to think of it in degrees, just to kind of help you as we're learning, this is really 180 plus 45 is 225 degrees. So that's really down here. Okay, so it's really going from here to here, rotating out. All right, so that's this angle. This is 5 pi over 4. Now the way to view this, again, 5 pi over 4, the 5 is larger than the 4, so this is bigger than pi, so it's bigger than 180. That's kind of like how my brain thinks about it. Right, if you take something and multiply it by something bigger than 1, it's going to be slightly more. So here's 180, here's slightly more than 180, right? That's how I knew roughly where to go. In any event, so theta is 5 pi over 4. The radius is 100 feet. So the question is, how far did I run if I had that angle cut off this part of the circle? How long is this? Well, S equals r theta. S equals the radius, 100 feet, times the angle in radians, which we said was 5 pi over 4. And so that's equal to 100 over 4 is 25. Times 5 pi, and so that's 125 pi. And the units here would be feet. And again, you could use your calculator. This would be, roughly this times 3, so it'd be 370 something, 380 something feet. All right. And so this is how you find arc length. It comes from this very simple formula. It can be used in a few different ways, but this is the general use of this.